Okay, so sorry for the background noise. My son is playing and he's watching Moana. But as far as my homework goes, this is Oscar's Chapter 5 homework problems. So we have 5.1, 5.9, 5.11. On the back, we have 5.14, 5.18, 5.23, right there, 5.27, and then we also have 5.59. And the problem I chose to talk about is 5.18, and that's dealing with a car safely negotiating on an unbanked turn, circular turn. So the free body diagram for that problem would look like this, with normal force going up, mg shooting down, and frictional force going to the right. And then we know that acceleration is shooting to the right. So acceleration would equal to v squared over r. That would be the formula for acceleration. And we know that velocity is equal to 21 meters per second. And since F is equal to mv squared over r, we know that we'll plug that into the F equation, which is mu times n. And to find n, we need to find the y-axis, the y formula. So we know that would look like n minus mg, which is equal to 0. And then you would take the you would move the mg to the right side, which would make n equal to mg. So you would take what we just found for m, plug it into the formula of f, and we know that f is equal to mv squared over r. So we took that and moved it down here, and we put m times v squared over r, which is equal to mu mg. So we need to get velocity by itself. So since we need to, so what we have to do is divide m to both sides. So we can cancel out one m, and then we can cancel out the other m, because there's two m's, one on top, one on bottom. And like we said, we're trying to get v by itself. So the next step would be v squared equals r times mu times g. Still not by itself yet, so we decided to take the square root of the right side to get v by itself. So v equals the square root of r times mu times g. So now we have the velocity, which is equal to u times the static frictional force. And we know on the problem that it says that the static frictional force is one third of its dry road value. So we can plug in, we know that velocity is equal to 21 meters per second. So so this equation, when you plug it in, it would look like 21 meters per second times the square root of 1/3. And once you do that and get that solution, you would end up with 12.12 meters per second, in which the car should slow down to.